Okay, dear students, now I will solve question about section 4, which is everyday forces. I choose practice D questions, problem 1 here. Horizontal force of 53 Newton keeps a 24 kilogram crate moving with constant velocity. Pay attention here, it keeps moving, so kinetic friction here wanted. So find it say mu k, the coefficient of friction between the crate and the floor. Let's draw a free body diagram of the crate, friends. Here, if we draw crate, assume this is the crate. It's on a surface, and of course a force is applied. It says a force of 53 Newton is applied. It is moving. This force is needed to keep moving. So what does it mean a force is applied and it's moving with constant velocity? It means that there is an opposite force here, which is friction force, F friction. And that the second, since there is an F friction, we have to draw an Fn. This object, box or crate, we say the crate has a weight, Fg downward direction, and this Fg is supported by an external, by a force Fn, normal force, Fn here. So if we draw this velocity to the left, let me arrange it again, sorry. Then Fn applied on it, this is the crate, and Fn here. It's moving with constant velocity. So if you remember a friction force, we learned that friction force is equal to mu multiply Fn. So here F friction is unknown and Fn is unknown. When you look at the perpendicular forces, since it is in equilibrium, in vertical it is in equilibrium. So I can write the forces total Fy is equal to 0. Which forces we have? Fn plus Fg is equal to 0. These are vector addition. And Fn upward direction plus Fg minus direction. Fg is equal to 0. From this equation, we can say that Fn is equal to Fg. Let's calculate Fn. As you know, Fg is weight, so it's multiplied mass multiplied g. Fn is equal to mass is given as 24 kilogram. 24 multiplied g is 9.81. Then Fn here will be 24 multiply it 335 Newton, around 335. Yes, we calculate Fn. Now F friction wanted in horizontal, it moves with constant velocity. Means that Fx, total Fx is equal to 0. Fnet is 0. So here total Fx 0. Let's add them. F applied force to the right plus F friction is equal to 0. When I write them, F is right and F friction is left, so I should put here minus F friction is equal to 0. Then F friction is equal to F applied here. So F friction is 53 Newton. I calculate F friction and I calculate Fn. Now I can use this equation in order to calculate coefficient of friction. Now as we say, F friction is equal to mu multiply Fn. Here, since kinetic friction called, we say F kinetic is equal to mu k multiply Fn. Then we need F mu k. Mu k here is equal to Fk over Fn. This friction force is Fk because it is in motion, so we can say Fk here. Let's do it. Fk is 53 divided by 225. Then coefficient of friction, kinetic coefficient of friction will be 0.23. 0.23, around 0.23. Section is B. Okay, friend, the second question, also from everyday forces, same section, practice D. And second problem I choose now. 25 kilogram chair initially at rest, pay attention here, keywords, and 165 horizontal force is needed to set in motion. To move it, we need 165 Newton. What is the coefficient of static friction wanted? Again, let's draw the figure of the box. Assume it says a chair. Let's draw a chair here. It's a chair like this. Say that it is chair. Okay, it's a chair and it has 4 legs here, and a force of 165 Newton is needed to move it. 165 Newton needed to move it. And since there's a static friction between the chair and the surface, we draw F friction in opposite direction again. And it has a weight downward direction, Fg. And the ground will apply normal force on it, Fn. So these are the forces on the chair. Again, as we did before, since it is an equilibrium at rest, the horizontal and vertical forces must be same. Due to equilibrium position, total Fx is equal to 0 and total Fy is equal to 0. You have to calculate Fn and Fk as before. So horizontal forces, let's write. We have horizontal F plus F friction. These are equal to 0. These are vector addition. I will write now their magnitude. F to the right plus friction in opposite. So I will say minus F is equal to 0. From this equation, F friction is equal to F, which is equal to 165 Newton. But the friction force here, since it says static friction, I will use it as F static. It is equal to 165 Newton. I found Fs. Now Fy, vertical forces, F here, Fg plus Fn is equal to 0. Fg downward plus minus Fg plus Fn upward is equal to 0. Then we say that here, if we take Fg other side, Fn will equal Fg again. Then Fn will be mass multiply G. Mass multiply G. Then Fn is equal to mass 25 multiply G is 9.81. Then we say Fn is equal to 245, around 245 Newton. We calculate Fn and Fs. Now we can calculate mu. Mu is equal to friction force over normal force. Friction force here, Fs static friction, so we will say mu static. It is equal to static friction 165 divided by 245 Newton and Newton. So static friction between these two objects surface will be 0.67. Now we will solve the part B of second question from section D. In A, we calculate how much force is needed to move it. Now it says that the chair in motion and 127 Newton horizontal force is needed to keep it moving. What is the find coefficient of friction. And what we learn now, the chair is moving, and if we draw it again, let's draw the chair. This is the chair, and assume that chair is moving now with a velocity. It's moving. This is the chair. So it says that in order to keep it in motion, a force of 127 Newton is needed. So here again, it is moving. There is a kinetic friction between the chair and the surface, and it has a weight again, Fg, and it has a normal force, Fn. The ground will apply the forces. So in vertical, we calculate, as same as previous example, we calculate Fn is equal to Fg, and we know that Fn is equal to 245 Newton. And F friction is equal to F applied force, then F friction is equal to 127 Newton. 127 Newton, F friction, but here it is kinetic friction, don't forget it. Now mu k wanted, mu kinetic wanted. Mu kinetic is equal to F kinetic over Fn. Mu k is equal to F kinetic. We know that the force needed to move it, 127 divided by Fn is 245. Then mu kinetic will be here 0.52. This is the kinetic force between them.